It's a comet, now named 3I Atlas, and it's only the third object ever confirmed to have come from interstellar space.
On July 1st, 2025, a telescope in Chile noticed a tiny object moving through the darkness. At first, it looked like another distant comet, one more frozen body traveling toward the inner solar system. But when astronomers calculated its speed and traced its path backward, they discovered something extraordinary. This object did not belong here. It was moving too quickly to be held by the sun. Its path was not a closed orbit like those followed by the planets, asteroids, and comets born inside our solar system. It had arrived from interstellar space after traveling through the darkness between stars for perhaps millions or billions of years. Scientists named it 3I Atlas. The number 3 meant it was only the third confirmed interstellar object ever detected. The letter I stood for interstellar, and Atlas was the telescope system that discovered it. For the first time since Oumuamua and Borisov, materials formed around another star had entered our cosmic neighborhood. It was not a radio signal or a distant planet seen through a telescope. It was a physical piece of another star system passing directly through our own. And before it disappeared forever, scientists had only one chance to study it. The speck that should have not been there. 3I Atlas was discovered by the Atlas Survey Telescope in Rio Hurtado, Chile. Atlas was designed partly to search for asteroids and comets that could approach Earth, constantly photographing the sky and comparing each new image with earlier observations. Most moving objects found by such surveys belong to our solar system. Their paths curved around the sun because solar gravity holds them in closed orbits. But 3I Atlas behaved differently. When astronomers studied its trajectory, they found it was a hyperbolic path. It was moving too quickly for the sun to capture it permanently. The sun's gravity could bend its route and increase its speed as it approached, but it could not keep the object here. Tracing that path backward led beyond the solar system. This was not a comet returning after a long orbit. It had never been part of the sun's family. It had entered from the space between stars, made one passage through our planetary system, and would then continue into the galaxy. When it was discovered, it was already moving at approximately 137,000 miles per hour. As the sun pulled it closer, that speed increased, reaching around 153,000 miles per hour near its closest approach to the sun. It was not arriving to stay. It was passing through. The third visitor. Before 3I Atlas, humanity had detected only 2 confirmed objects from another star system. The first was Oumuamua, discovered in 2017. It was small, dark, and strangely shaped. Astronomers observed it only after it had already passed its closest point to the sun, leaving limited time to study it. Oumuamua showed no obvious comet-like tail, yet its motion contained a slight extra acceleration that could not be explained by gravity alone. Scientists proposed several natural explanations, including the release of gas that was too faint to detect clearly. Its unusual behavior also inspired speculation about artificial origins, although no evidence proved it was alien technology. The second interstellar visitor was 2I Borisov, discovered in 2019. Unlike Oumuamua, Borisov clearly behaved like a comet, releasing dust and gas as sunlight warmed its frozen surface. Then came 3I Atlas. This time, scientists detected the object early, giving telescopes and spacecraft across the solar system an opportunity to watch it approach the sun, become active, and then begin its journey outward. A comet from another sun. Observations soon showed that 3I Atlas had an icy nucleus surrounded by a glowing coma. A cloud of gas and dust released as the object warmed. This meant it could be classified as a comet. But calling it a comet does not make it ordinary. Every comet formed inside our solar system contains clues about the cloud of gas and dust that surrounded the young sun. By analyzing its ice, gases, and minerals, scientists can study the ingredients that existed before Earth and the other planets fully formed. 3I Atlas carries the same kind of record, but from somewhere else. It formed around another star, inside a planetary system whose location may never be identified. At some point, perhaps during the violent rearrangement of planets, it was thrown away from its home. A close encounter with a giant planet could have accelerated it beyond the gravitational control of its star. Once ejected, it would have entered interstellar space with no new star to orbit. For an unmanageable length of time, it traveled through the galaxy. Then, chance brought it through our solar system during the brief period when human beings possessed instruments capable of detecting it. Its chemical fingerprint was different. The greatest value of 3I Atlas was not its size or appearance. It was its chemistry. Telescopes observed the light passing through and emerging from the clouds surrounding the comet. Different molecules interact with light in specific ways, allowing scientists to identify gases without physically touching the object. Early observations revealed that 3I Atlas was usually rich in carbon dioxide compared with water. This ratio differed from what astronomers normally observe in comets formed around the sun. Later, the James Webb Space Telescope detected methane gas around the comet, the first direct methane detection on an interstellar visitor. The amount of methane compared with water was surprisingly high. With few close equivalents among familiar solar system comets, scientists believe some of that methane may have been buried beneath the surface, protected until heat from the sun reached deeper layers after the comet's closest approach. These differences do not mean the comet violates physics. They mean it may have formed under conditions unlike those that produced most comets in our solar system. The solar system watched it pass. NASA organized an extraordinary observation campaign involving telescopes, planetary missions, and spacecraft positioned across the solar system. The Hubble Space Telescope photographed the comet's icy nucleus and its surrounding cocoon of dust. The James Webb Space Telescope studied its infrared chemical signature. Sphere X examined water, carbon dioxide, organic molecules, and dust in its coma. Spacecraft near Mars received an especially valuable view when 3I Atlas passed approximately 19 million miles from the planet. The Mars Reconnaissance Orbiter, MAVEN, and the Perseverance rover all observed it from their different positions. Other missions, including Parker Solar Probe, Europa Clipper, Lucy, and Psyche, also collected information as the visitor moved through the solar system. This was unlike observing a distant exoplanet around another star. With exoplanets, scientists analyze faint light crossing enormous distances. It was never a threat. A title about an unknown interstellar object can easily create fear. But 3I Atlas was never on a collision course with Earth. At its closest, it remained approximately 170 million miles from our planet, nearly twice the distance between Earth and the Sun. Its path was calculated and refined as more observations became available. The object behaved consistently with an active natural comet. Small changes in its motion could be explained by outgassing as sunlight warmed its ice and released material. There was no confirmed evidence that it was a spacecraft, a probe, or something deliberately sent toward us. The true mystery was already powerful enough without exaggeration. A natural object from another star system had entered ours. Its material had formed beneath another sun, escaped its birthplace, and crossed interstellar space before appearing in human telescopes. That is more remarkable than any unsupported alien theory. A visitor we could not follow. After passing closest to the Sun on October 30th, 2025, 3I Atlas began moving outward again. The Sun slowed it as it departed, but not enough to reverse its journey. The comet remained unbound and continued beyond the planets toward interstellar space. No spacecraft could catch it. By the time it was discovered, it was already traveling far too quickly for any mission prepared on short notice. This is one of the greatest frustrations surrounding interstellar visitors. We can watch them, measure them, and photograph them, but we cannot yet reach them. Future missions may change that. Scientists have considered spacecraft capable of waiting in space and responding quickly when another interstellar object is detected.